Today's topic is the peopling of the Americas. Only modern Homo sapiens spread to the farthest reaches of the world, into the far upper northeastern reaches of Siberia, into Australia, which required boats, and into the New World, that is, North, Central, and South America. This spread occurred during the Pleistocene, the Ice Age, when glaciation caused low sea levels, allowing some land masses to be joined. Let's start with a little bit of vocabulary. New World means North, Central, and South America, as opposed to the Old World. Paleolithic is a European cultural period, meaning the Old Stone Age. Paleo, old, lithic, stone. Pleistocene refers to the Ice Age, a geological epoch lasting from approximately 2.8 or 2.6 million years ago to 11,700 or 10,000 years ago. Beringia, named after the Bering Sea, was the land bridge that connected Siberia and Alaska at peak glaciation. It's also called the Bering Land Bridge. And the ice-free corridor refers to an open land passage across Canada between Alaska and the rest of the continental United States that occurred between two glacial masses as they pulled apart. In telling time, I use a lot of different initials. We've covered some of these before, and I'll just let you read through these. A new one here using Ka for 1,000 years ago. BP, before present, which relates to radiocarbon years before present. And if you recall, radiocarbon years are not the same as regular years. So when they've been calibrated, that means they've been converted to the actual years. The Pleistocene epoch began about 2.6 million years ago and lasted until about 11,700 years ago. It included perhaps 15 cold periods when glaciers covered parts of the world, as you can see in this illustration. In between, when it got warmer, which we call interglacials, the ocean levels rose again. So this was a very dynamic time. Here you can see the North American continent during the Pleistocene epoch glaciation period. Note that the shorelines were wider because as glaciers took up seawater, the sea level dropped. In fact, glaciers got up to 2 miles thick, and the glaciated areas were uninhabitable. This illustration shows you how deep the ice sheets were over some modern-day cities. During periods of glaciation, sea levels dropped over 300 feet, and much of the Earth's water was tied up in glaciers. In many places, what was the shoreline is now out to sea. For example, here in black, you see the present-day coast of Florida, and the red dashed line shows the Pleistocene glaciated coastline of Florida. What this means is that if people were living on the shoreline, today you would have to go out to sea in a boat and do deep underwater archaeology to find those sites. And we don't yet have the capability of doing archaeology at those depths. Not only was Siberia connected by land to Alaska, but also Central America was wider. Pleistocene environments were dynamic. Glaciers stripped materials from their centers and deposited them at their edges. The Great Lakes formed as glacial lobes scoured out weak rocks in low areas. The continental glaciers came only as far south as the Ohio River in the New World. A narrow 200-kilometer zone of permafrost extended out from the southern glacial edge. Meltwater coming off the glaciers carried a lot of sediments, resulting in rivers that looked like this with braided channels. Obviously, it did not look like it does now. Our current understanding of human migration into the Americas depends on two major forms of evidence: archaeological sites, of which we have few very early sites, and genetic testing of both ancient and modern populations of both humans and dogs. Several questions or controversies have arisen over the colonization of the New World. The first of these asks, what routes did people take to enter the Americas? When did people enter the New World? How many waves of migration were there? And a historical question at this point is, what does Clovis represent? And we'll talk about Clovis in a few minutes. Let's begin by looking at what route people took to enter the Americas. The first route that was proposed was that people walked across Beringia inland and entered across through the ice-free corridor into the rest of the New World. This route is marked with an A in red. The second hypothesis posited that people boated along the Pacific coast. This is marked in blue with the B. And the third route that people have proposed is that people boated from Europe across the Arctic Ocean along the shore, also called the Solutrean solution, and this is marked in C in black. Traditionally, we thought that immigrants walked here by following big game across the Bering Land Bridge. Beringia, or the Bering Land Bridge, was exposed continuously from 35,000 to 11,000 years ago. Here's the problem with the first route. Once you walked across Beringia and reached Alaska, you were stuck because you could not traverse glacier-covered Canada. Glaciers covered the route between Alaska and the rest of North America between 26 and 19,000 years ago. It's not until an ice-free corridor opened up near the end of the Pleistocene between 15 to 12,000 years ago that you could walk from Alaska down into the rest of the North American continent. We do know that this ice-free corridor was open and animals were traversing this passage by about 13,000 years ago. The second route that has been proposed is the Pacific coastal route that states that seafaring boaters hopped along the coastline of southern Beringia, western Alaska, and crossed down the western coast of North America, Central America, and then down into South America. The opening of a passage along this route is tied to the recessional history of the Cordilleran ice sheet that exposed the continental shelf and extant islands. And this ice margin began retreating by about 17,000 years ago, making it possible for people to boat along this edge and or sometimes walk a bit. This map shows key dated sites along both the proposed inland and coastal corridors. And you could note immediately that the inland sites are all much more recent, much younger, dating between about 14.2 thousand years ago to 11.6 thousand years ago, whereas the coastal sites are older, supporting the idea that this was the route that the earliest colonizers of the Americas took. The least accepted and in fact debunked hypothesis was the so-called Solutrean solution, that people came across from Europe, not from Asia, by following the coastline in boats. Now, why did someone even dream up this hypothesis? Well, it was because the Solutrean points found in Europe were very finely made, very finely worked bifacial points that reminded them of the workmanship that went into the Clovis points found in the Americas. However, Solutrean points were not made past 16,000 years ago, and Clovis points in the Americas were not made until 13,000 years ago. Regardless, genetic studies conclusively show that the first Americans did not originate from Europe, as posited by the Solutrean hypothesis. So, the drop in sea level exposed the shallow Bering Sea floor between Siberia and Alaska, hence the name Beringia. And this was present, this landmass, from 34,000 to 11,000 years ago. People are thought to have moved into southern Beringia between about 26,500 and 19,000 years ago. Note how you could walk to Alaska, but then your way further south into the rest of the North America was blocked by these two glacial sheets. So a new study has found that the Bering land bridge's climate became wetter and warmer about 15,000 years ago. And the research team was able to show shifting climatic conditions in the past from the Bering land bridge by examining fossils from bugs, plants, and spores. Many of those organisms live in specific conditions, so their presence offers evidence about past temperatures and moisture levels. A marked climate shift to wetter, warmer conditions on the Bering land bridge coincides with the earliest appearance of humans in Alaska. So scientists have found archaeological evidence in Alaska that dates human habitation there as far back as 14,200 years ago. The climate shift likely meant a transition from steppe to forests in eastern Beringia, that is, into Alaska. Meanwhile, horses declined in interior Alaska as moose appeared, which of course could have affected human hunting practices and food availability. The arrows here indicate the directionality of the proposed first migration to Alaska across Beringia, and then the back migration of Paleo-Indians through the ice-free corridor around 12,000 to 13,000 years ago. So the blue dots, dark blue dots, indicate those of one lithic tradition, and the light blue dots indicate a separate kind of cultural tradition sites. But one of the things that this map illustrates is that people weren't just coming from Siberia into Alaska and down into the Americas, but they were also coming back. The little green outlines indicate national parks in Alaska. The earliest unequivocal evidence of humans in eastern Beringia appears at the Swan Point site in central Alaska. And here, wedge-shaped microblade cores were used to make small blades that were inset into bone projectile points between around 14.2 thousand years ago. And this microblade technology is similar to or derived from the Siberian Yuktai culture of central Siberia, which dates to about 18 to 12.6 thousand years ago. So in other words, we do see a cultural link between the stone tool technology among the earlier Yuktai cultures in Siberia compared with the early sites in Alaska. The first Americans moved south of the continental ice sheets that covered Canada sometime between 17.5 thousand and 14.6 thousand years ago, according to the genetic evidence. They encountered megafauna such as woolly mammoth, and in fact, North America was dominated by creatures that resemble large versions of today's wildlife, including giant bears, giant cats, giant beavers, giant wolves, and giant bison. Interestingly, the evolutionary history of dogs helps tell us about the history of human movement. So genetic analysis of dogs, which accompanied the first Americans on their journey from Eurasia to the Americas, provides additional insight about the timing of the arrival of the first Americans. The dogs that traveled with the first Americans originated in Siberia and split from Siberian dogs sometime between 17.6 and 13.7 thousand years ago. And these pre-contact American dogs were south of the ice sheets by sometime between 16.5 and 13,000 years ago. Ancient and modern human genomes show that the ancestral indigenous American population emerged in Eurasia, descending from a single founding group that split from the ancestral East Asians about 36,000 years ago. And yet they maintained a high level of gene flow with East Asians until at least 25,000 years ago. And this ancestral population also received gene flow from ancient Siberian populations that had northern Eurasian ancestry until about 25 to 20,000 years ago. Afterwards, the ancestral indigenous American population became isolated from external gene flow. Now, the people living in Beringia were not genetically homogeneous. But sometime between about 22,000 and 18.1 thousand years ago, ancient Beringians branched from the ancestral indigenous Americans. Yet both populations maintained gene flow between them until at least 11.5 thousand years ago. And sometime between 17.5 and 14.6 thousand years ago, groups from the ancestral indigenous American population split into two branches, the northern Native Americans and the southern Native Americans. And the location of where this divergence took place most likely occurred either while the groups were migrating south from Beringia or after they had entered unglaciated North America. So we see populations crossing and then splitting. Once south of the ice sheets, one branch became geographically restricted to northern North America, whereas the other branch populated most of unglaciated North and South America. The movement of people from North to South America took hundreds or a few thousand years. Analysis of genetic variation across South America modern populations shows that when early hunter-gatherers reached the northern edge of South America, they advanced southward along two main routes, the Atlantic and the Pacific coasts. In other words, South America was populated by seafaring boaters. So how could you possibly tell where colonizers came from? We'd look for earlier sites in the potential source area. You'd look for the same styles of artifacts, such as we've already seen with Yuktai culture and Central Alaska sites. So you'd look for the same styles in the source area and in the earliest American sites. And you'd look for genetic similarities between the source area and the earliest Americans. And that is the migration outline given here so far. The Clovis first hypothesis refers to a belief that archaeologists held until fairly recently that a particular type of artifact called the Clovis point, illustrated here on the right, was left behind by the earliest American colonizers. That if you found one of these points, and you can find them right here in South Carolina, you found evidence of the very first people to come across from Asia. So the Clovis point is a very distinctive, large, lanceolate-shaped, fluted spear point. And that fluted refers to that flake, that long flake that comes up from the base. And you can see that that is used to help haft the spear point onto a shaft. It is found across eastern North America, that is, east of the Rockies, from about 13,000 to 10,850 years ago. We now know that this is not true, that the spread of the distinctive Clovis points is not related to the spread of the first arrival Americans. Instead, other people were already here, and when you find a Clovis point, you're finding evidence of the first kind of fad of style, that people liked this point and they started making it. So it's the spread of a technology rather than the spread of brand new people. So archaeologists started to dig deeper than the Clovis layers. You know, back when they thought that Clovis was the earliest, they found Clovis and they stopped digging. They said, these are the first people. There can't be anything below this. But a few archaeologists went deeper and they started finding earlier artifacts. They had thought so long that Clovis was first that many had difficulty accepting anything earlier. So this controversy led to two competing hypotheses about the peopling of the Americas. Clovis first, meaning Clovis were the first populators, and that's the style of point that they made, versus pre-Clovis, the people were here before Clovis. So The Pre-Clovis hypothesis states that people were already here making other sorts of less durable tools and or less distinctive tools. I mean, let's face it, that Clovis point is highly distinctive. Anybody could recognize it. So Clovis then represents the spread of a new technology rather than the spread of the first colonizers, according to the Pre-Clovis hypothesis. So when did people arrive? Well, we now know that they were living near the tip of South America by 14,000 years ago at the Monte Verde site in Chile. Although this was very controversial when first found, this is now a well-accepted date of 14,000 years ago. And this site has incredible preservation. I think it was in a bog, and so you have organic remains such as this cut wooden stake are preserved. Obviously, for people to have entered via the Northern Hemisphere and to have reached the southern tip of South America by 14,000 years ago, those people must have entered America well before 14,000 years ago. That is, well before Clovis points are found at 13,000 years ago. But one problem exists. The walking route across Beringia to Alaska was available. You could get from Siberia to Alaska, but once there you were stuck because the ice-free corridor that got you across Canada was not yet open. And this problem led to the origin of the coastal access hypothesis. So currently it appears humans were in the Americas by at least 15,000 years ago, if not longer. And starting about 13,000 years ago, the first regional archaeological complexes in North America emerged. The Clovis complex, east of the Rockies, and the Western Stemmed Point tradition, west of the Rockies. So this is starting to show some kind of cultural differentiations. This map illustrates sites dating between about 15,500 years ago to 13,300 years ago in the Americas. And these are sites that the author of this article deemed to be the most well documented. Now there are other sites that date to this time period or even earlier that are not on this map. But I do want to point out the one that I've marked with the big red dot, the Page Ladson site in Florida. Page Ladson is the oldest radiocarbon dated site in North America that has both stone artifacts from early colonizers associated with bones of extinct animals that they were hunting. And in particular, they were hunting mastodons and not only eating the meat and fat, but using the bones. One site not on Waters' list is a site here famous in South Carolina, found on the Savannah River, the Topper site. Here, there's a very clear Clovis layer illustrated up toward the top of this profile. But once Dr. Al Goodyear, the excavator of this site, dug deeper, he found an ancient Pleistocene terrace with artifacts. And so he says that people were here perhaps as early as 20,000 years ago, and even more controversially, perhaps as early as 50,000 years ago. Here are some of the Clovis artifacts. You can see that the top two broken Clovis points with that flute coming up. So these were perhaps, I'm not sure, impact fractures and or fractures that occurred in the making of these tools. And then a very large blade made from a prepared core. First is examples of artifacts from below the Clovis layer. And you can see at the bottom center, H is a core for making very small blades. The kind of blades that you would need to inset into a bone handle to use. Also, they find examples of what they've called bend break tools, and these are flakes that they've simply snapped off against a rock, and this gives you a very sharp little point. And then they have hafted one of these. You can see the sharp point off to the left on the bottom with the wooden handle that you would hold. And you could use this sharp point to tattoo people or to etch lines into mastodon or mammoth ivory tusks or into bone. So we do have a growing number of archaeological projects in Siberia, the source area for the people entering the Americas, but still relatively little archaeological investigation across this huge area. This map shows some of the Paleolithic sites in northeastern Asia. And in particular, I've put a red dot at the Yana RHS site dating to 29.5 thousand years ago up on the edge of the Arctic Circle. And please note also the Ushki sites and the Yuktai cave site over on the east side, over toward the Kamchatka Peninsula. The SK Mammoth site has been found in the central Siberian Arctic dating to 45,000 years ago. And although we don't have any human bones and no human tools, we do have a mammoth who evidently had been killed and butchered by people. So there are cut and puncture marks both from when the mammoth was alive and then after he was dead when people were cutting off meat and fat. The Yana RHS site, RHS stands for rhinoceros horn, dates to 29,650 years ago, found in the Arctic Circle of eastern Siberia during the Pleistocene. That's incredible. The people here were hunting megafauna and large game. Now, it turns out that when humans were present at Yana RHS site, the interstadial climatic conditions meant that a large stretch of the Arctic coast of northeastern Siberia was suitable for human occupation. They found there one rhinoceros horn and two mammoth ivory atlatl fragments. An atlatl is a sort of spear thrower. And the lithic assemblage includes core tools, bifacially flaked pebbles, choppers, scrapers, and a hammerstone. This picture is a little misleading because it only shows two artifacts. On the left, the rhino horn foreshaft on both sides of it, and then on the right, a wolf metatarsal bone with multiple cut marks. And so it shows different views of that wolf bone and then a close-up of some of the cut marks. And these are cut marks from stone tools made by humans. Again, here are artifacts showing 5 of them, both sides of each artifact. That one on the bottom left is an end scraper, the kind of tool you would use to prepare hides to turn them into leather. Genetic evidence now tells us that the people who lived at the Yana RHS did not contribute to Native American ancestry. Instead, conditions there became inhospitable, and the area was not reoccupied until about 20,000 years ago. At 20,000 years ago, these new people had a distinctively different stone tool technology, a blade technology like we do see over in the Americas, and they were genetically different also. However, the Yuktai culture does look similar to some of the early artifacts that we find in Alaska. These sites are no older than 18,000 years ago and probably mostly concentrate between 14 to 12,000 years ago. They're characterized by, among other things, microblade scrapers. So they were making prepared cores and then flaking off these blades. They were hunting mammoth and musk ox. And these people do appear to be related to the migrants to the Americas. Yuktai culture was widespread across Siberia and up into the Kamchatka Peninsula, highlighted here in kind of an orange. This shows some of the microblades. So up there on the top right, you can see a very teeny tiny blade struck from a prepared core. How could you use that? Well, in the kind of bottom left, it shows inset into a bone, how you could inset and make kind of a hacksaw blades, as it were. We also find Ushki sites in the Kamchatka Peninsula on the south shore of a lake, dating from 13,600 to 14,300 years ago. And here you can see in this profile many different layers of ash from different volcanic eruptions, allowing us to date or to bracket the time period that people were living here. At Ushki sites, they've found houses and hearths, bifaces and unifaces, burins for carving, etching lines into bone, and also cores for making blades. So in other words, so far we have one 29,000-year-old site in Siberia where the colonizers of the Americas did not originate. And we have genetic evidence that the ancient Paleo-Siberian Native American lineage diverged from present-day East Asians about 30,000 years ago, and that our populations in the Americas diverged from the ancient Paleo-Siberians about 24,000 years ago. So we need a lot more archaeology done, and perhaps you'll be the person who digs in Siberia or who figures out how to excavate sites 300 feet deep out in the ocean on what used to be the coastline. The majority of Native American genetic ancestry is likely to have originated in northeastern Siberia rather than in south central Siberia. So far, fewer than 30 of the skeletons predate 8,500 years ago. So we have very little direct genetic evidence from the earliest colonizers themselves. To summarize, modern Homo sapiens immigrated to the New World from Siberia. They were near the south tip of South America by 14,000 years ago. And it appears that the distribution of Clovis points found between 13,000 to 10,850 years ago does not equate to colonization by these Asian immigrants, the so-called Clovis first hypothesis, but rather signals the adoption of a new technology of peoples who had already colonized North America. So we are accepting the pre-Clovis hypothesis, that people were here prior to Clovis and that Clovis represents the spread of a technology rather than the first immigrants. It appears that the route taken was the coastal access route. That is, the earliest colonizers of the Americas boated along the west coast. Later migrants easily walked inland. Like Upper Paleolithic people in the Old World, these earliest colonizers appear to have been making and using blade tools made from prepared cores. And they certainly had boating technology to reach Australia by 65,000 years ago, so there's no reason to suppose that they couldn't have had boats to reach America. And there likely was not just one wave of migration, but rather a long continuous exchange of people going both directions, also going from Americas back to Siberia.